This is Official Nerd Business.
Hello nerd boys and girls, welcome back to our Euler series. Today we will be taking a crack at Euler Problem number 37, Truncatable Primes. We will be doing so using Python 3 and the PyCharm IDE. And as you can see, that is already opened in front of us. And I've already created the template file for all of our solutions with at top the docstring with the title of the Euler problem, any parameters we want to take in and default values for them, a tagline which we don't use at the moment but maybe they'll come soon, and then description of the problem. The number 3797 has an interesting property. Being prime itself, it's possible to continuously remove digits from both the left and the right and to remain prime at each stage. So here's a deconstruction of the right side, and here's a deconstruction from right to left. And every iteration the resulting number is prime, so we take one digit away from the left side, we take one digit away from the left side, etc. And every iteration is prime, and then we do the same from the right side. These are truncatable primes, and these are doubly truncatable primes, so from left to right and from right to left. Find the sum of the only 11 primes that are both truncatable from left to right and from right to left. And a note that the single digit primes are not considered to be truncatable. There's no trunc operation for these guys because trunking anything from them would leave you with nothing. So they are not considered to be truncatable. Now the weird thing is, there's no mention of any kind of limit, but we do have this up top, so I think I've made an error in creating this template file, and I'll remove it for now. This doesn't seem to take any parameters, and if we do need something of a parameter later on, if we find it that our code functions better within a certain given input, then we'll add it back. So how are we going to set this up? We know that we will have a resulting list of truncatable primes, and we know that this will eventually hit 11. Items in this list, and until then, let's get cracking. So the first prime we want to consider is 11. So in fact, we already know that this isn't going to work for 11 because it's any reduction to this, any truncation to this will give us 1, and 1 is not considered to be prime. So we'll need a mechanism where we test the number, and if it's not what we want, or if it is, but then we're going to increase that number by 2 because we are only interested in the odd numbers, test if that is prime, and then run the truncation test. Since we know 11 won't work, we can set up our logic in such a way that we first increment and then do all the testing. So let's, in fact, it should not be called prime, but let's say candidate. I'm gonna bring in our Euler library so that we can now say if E dot is prime. And this, by the way, is not going to take a limit, as is this. Also not this. Alright. So, a lot going on here. We're gonna test if this is a prime, then we're gonna test if the left trunking property holds. But we do need to create that function. Def left trunk on candidate. Let's just bring it in as n. Now we're gonna left trunk it, so we're gonna take we're gonna have a number ABCD. We're gonna chop off the A and gonna check if this still is prime. Then we'll chop off the B, check if this still is prime. Then we're gonna chop off the C, etc. So we want to loop for any I in range. Well, we're gonna start at 1. We're gonna run all the way up to the entire length of the string. So we're gonna first run a test to see if this function actually does what we want. We're gonna get some substrings, and we're gonna use these slicer methods again. So we're gonna start at index. We now have a string copy of the number coming in, so this number is an integer type, but we want a string type because slicing it, trimming off elements is easier on the string than it is on the number. And we want to start at index I, and then run all the way up to the end of the string. We're gonna deactivate this bit of code, and we're gonna say left trunk 1, 2, 3, 4, and we're gonna run this. I hope it'll ignore the syntax error. Yes. Alright, so we can see in the output here, we gave it 1, 2, 3, 4, and we got back 2, 3, 4, 3, 4, and 4. Why is 1, 2, 3, 4 not in here? We're not gonna test 1, 2, 3, 4 because we already know that's prime. That's this test. It passed this test, so it's guaranteed that the full thing is a prime. So the first thing we're interested in is a trimmed version. That's why this starts at 1 and not at 0. Note that if we do have the string A, B, C, D, and we were to refer to any character in it, the 0 would refer to the A, and the 1 would refer to the B, 2 and 3. That's why this works. We have a 4-length string in here, and we can replace this now by the S. We have a 4-line string in here, and we're never going to put in a 4 here because the range function by default in Python will not include the final element, which is 4 here. So this will run from 0 up to 3, but we tell it to start 1. This runs from 1 up to and including 3. So we get a substring starting at 1, starting at 2, starting at 3. 3 different substrings, all a little bit smaller than the previous version. So we want to test if hang on, there. We want to test if the integer version of this is prime again. E.is prime. or in fact we want to test if it's not really. Because then we can quit early if any of these iterations, and 1, 2, 3, 4 itself is obviously not prime, but if 2, 3, 4 is not prime, then we will quit on the first iteration, and if it is, we will enter another iteration where we test 3, 4 and see if that's prime, and if that is or isn't, etc, etc. And finally, if we didn't quit early, then the whole thing truncated is an actual prime. So let's see if we were to do this. We're going to disable the right trunk testing, and we're simply going to pick up primes until we've seen 11 left truncatable primes, and print out that array. We're not going to print anything from the trunc function itself. And 13 and 17 are considered to be left truncatable primes, because 13 is prime, and when we drop the 1 we're left with 3. 3 is also a prime. And as you can see, we find 11 instances of this below 100, so that's kind of fun. Note that the 13 and the 17 and also the 23 will all disappear when we start checking for right truncatability, because then we will trunk the 3. And we will be left with only the 1 which isn't prime, or only the 2 which isn't prime. The same goes for 47, 67. So there's a lot of numbers in here that will be filtered out again by the right truncate property. So let's get that into place. And for that we're basically going to use the same function. I do want to make it a separate function because because of this bit. I mean, let's figure out how we can do right trunc. So we want to have the end of the string, but nope. We want it to start at the start, and we want to take all of the characters -1, -2, -3. So we can do this. Or we could swing this around. So we could say start at length S, move all the way back down to 1, or 0 in fact. We don't want this to start at 4. Note that now that we are making this the starting element of our range object, that 4 for our 1, 2, 3, 4 example, and length 4 will be our starting point, but we don't want to take any 4 characters. So I'm going to subtract 1 from it. We're going to run up to but not including 0, so we always take at least 1 character from the string, and we're going to progress through this at a negative pace. And we're going to start at 0, but we can omit that if it is 0, and then we're going to take I characters. So let's see if I'm going to comment this out for a second. Take this particular thingy and simply print it to see if our assumption is correct that this will give us a right trunc. Again, we're going to input 1, 2, 3, 4, and now we're expecting 1, 2, 3, 1, 2, and 1, which is exactly what we got. Alright, I'm going to re-enable run here, and we're going to throw out the print here, and then we're going to re-enable the actual code. So this should give us our right truncatability. And in fact, I'm gonna flip these around. It's, as we've seen with the left trunk property, it's kind of easy to hit numbers like 17 or 23 or things that have digits that are definitely not prime. I think if we were first to test for right truncatability, the selection that we'll have to test for left truncatability will be smaller, and we will be sooner to hit an actual left truncatable prime. And that way we will reduce the amount of tests we need to do, because we'll simply be looping through this function less often when we first wheel out the right truncatable primes instead of the other way around. So there's that. I'm gonna leave in the print R so that we can see what primes end up being right and left truncatable, and we're gonna return the sum of all of those primes as per requested. Alright. There's a nice list of primes, and we are going to run this through MainPy to also get our timing information. I want to run 37, please. In 1.5 seconds it listed out our 11 primes. And if you go over to Project Euler and you enter the number shown on the screen here, you will get a green check. So that's it for problem number 37. It's kind of a simple one. I'm not going to try to optimize this very much because it's really just truncating the numbers is just that. It's just a lot of there's not much math involved. It's just a bit of programming, and fortunately Python helps us a great deal with their list and string slicer methods here. So that's particularly nice. We've once again seen the new feature, in fact, of the range. I don't believe we've run through things backwards yet, so there's that. Yeah, so all in all, it's a nice, neat little function here, and it took us 1.5 seconds to find that this 6-digit number is a left and right truncatable prime. So that's all in all not bad. Don't forget to check out my GitLab if you have any questions about the lib Euler or this solution in particular, or anything at all. Look it up on GitHub, see if you can figure out my code there, and if you have any questions, leave them down in the comments. And I will see you again next time for problem number 38.
Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.